Hi guys, welcome to this second instalment of this Research Methods Statistics lecture series. Hopefully you guys are as excited to be here as these two minions clearly are. So up until this point of the module, we've covered descriptive statistics. We have introduced the concept of inferential statistics, and we've covered the use of correlation tests to investigate questions about relationships. So in this video lecture, and for the next couple of weeks, we will be exploring this concept of inferential statistics a little bit more, and we will be applying statistical tests to investigate questions which involve looking for differences between two groups of data. But before we delve into this new realm of statistical tests, we should just recap on some of the key terms and concepts that you've covered previously and are likely to come across again in these coming sessions. Now, what I'd like you to do at this point is to pause the video. Okay, and what you can do is you can scan this QR code, which will take you to an online revision platform called Quizlet, where you can test yourself against some of these terms and definitions. Alternatively, you can find this Quizlet link on Moodle in the same place that you found this online video lecture. Okay, and what I want you to do once you get to that quiz is to use the match game. Alright, there are lots of revision tools on here, but the match game is the best one for you to use for this task. Okay, hopefully now then, you guys are all swatted up, so when I mention some of the key terms in this video, you don't completely freak out and you're able to stay with me. So in this lecture on tests for differences, we will be touching on some of the same concepts as we did with the correlations test that we did previously, although the research questions will be inherently different. So for example, when we were asking questions about correlations, what we wanted to know was, is there a correlation or relationship between two variables? So for example, variable x, which we'd find on a horizontal axis of the graph, and variable y, which we'd find on a vertical axis of the graph. However, when we ask questions about tests for differences, what we want to find out here is there a difference between the observations of different groups? So in this example, we could ask, is there a difference in the shape of poo between two different groups that have experienced two different types of treatment? So there are a couple of key similarities between the tests we did before and the tests we're going to be doing over the next couple of weeks, which we'll just touch on a little bit now. So although the research questions surrounding the different types of tests might be different, as we just saw, the tests work in similar or on using similar underlying principles. So the first one of these then is the principle of the null hypothesis. Hopefully at this point you guys are all familiar with what the null hypothesis actually is. So when we performed correlation tests, we were testing the null hypothesis, and the null hypothesis was that there would be no correlation or relationship between variable x and variable y. So for this, we used the p-value to decide if we would accept or reject this statement. For example, if the p-value was over 0.05, we accept the null hypothesis, and we say there's no correlation between variables x and y. However, if a p-value is less than 0.05, we reject the null hypothesis and accept the alternative hypothesis, where we say there is a correlation or there is a relationship between variables x and y. So remember, if we're rejecting the null hypothesis based on this p-value less than 0.05, what we're saying is that over 95% of our data can be explained by the variables of interest. So in a similar fashion then, a test for differences of two groups will also have a null hypothesis. Now, can you guys make an educated guess as to what this might be? I'm going to give you 10 seconds to try and think about this. That's right, you guessed it. The null hypothesis of this kind of test is that there'll be no difference in the observations taken between different groups. In this case, between two groups. So the next similarity then between the test that we performed previously using correlations and the test that we're going to perform on tests for differences is that they both make similar assumptions about the distribution of your data in deciding what type of statistics test we might perform, parametric or non-parametric. So in relation to this, you'll recall that with the correlation tests, there were two possible tests you could use. One was parametric, called the Pearson's correlation, and we could use this test if we found that our data were normally distributed. And there was another test, the non-parametric test, called the Spearman's, and we can use this one if we found the data were not normally distributed, so if we had skew in the data. Now remember that this is really important in making sure that we choose the right test, because generally parametric statistics use means and non-parametric tests use medians. Okay, so if you've got skew in your data, it basically means that your mean is not representative of the middle point of your data set. Therefore, it's not representative to try and look for any inferences or make any conclusions from your data. So with the test for differences then, there's also parametric and non-parametric tests that we can choose between. But we also have to choose between independent and related samples data. And in the next video, we're going to look at how to make these decisions and what the difference is between all these different tests actually are. So at this point then, you guys want to head back to Moodle and click on the link for video 2.